So here we will solve the heat equation with the help of Crank-Nicolson method. So what happens is that this is the same thing where we try to predict the heat at the internal nodes. Heat at the internal nodes. We want to predict it. This one, this one, this one, and for that we have divide the rod into 4 segments. So there will be 5 nodes, 1, 2, 3, 4, 5, and this the total length of the rod is h. So each of the segment can be represented del h. So basically what happens is 4 del h is equals to h, right? So the boundary conditions are also given. That means what is the temperature at the 2 edges of the rod. This is one edge, placed at I is equal to 0, and this is another edge placed at I is equal to 4 node. 4. And this is at any time scale t, but at the initial time scale when t is 0, that is at the beginning, you can find the value of u at all the x's 1, 2, 3 with the help of this equation. This is given. U at all the x's when time is equal to 0. That is, it is in the initial stage. You can find the temperature at each of the node with the help of this equation. X by 3 is 16 minus x square. This x is your position of the node. So this is what it is. So the problem is there. The solution we have to make. Here what we have found is that u at I is equal to 0 is 0. Yes. U at I is equal to 4 is 0 degree centigrade, but at all the time scale, that means that t equals to 1, 2, 3 time scale. Or you can say it as t 0, 1, 2 at the initial stage, after first increment, after second increment. So they represented that t as j. So j is also equivalent to del t. So now what happens is, now if you want the solution, so you can find, you can develop this matrix. This is what the j is, time scale is, initial, first increment, second increment, and these are all the nodes. This is the first node, this is the second node, third node, fourth node, and fifth node. Fourth segment, so 5 node. If there is 3 segment, 4. And in the edge node, as you can see, as you can retrieve from the boundary condition, at the edge node, that is 0 and 4 node, 4th is the final node. Initial node and final node, left hand side, right hand side, both are 0 degree centigrade. So they are in 0 degree centigrade for all the time increments, correct? But for the other nodes, that means this 1, 2, and 3. This is U1, U2, and U3. Correct? At t is equal to 0, that initial time scale, initial stage, initial time, we can find out from this equation that at U2, 0, this is equals to 2 by 3 by 16 minus 4. So this is your 2 by 3 into 12. So 3, 4, these will become 8. So u at 2 in the initial time is 8. So here you see this. Okay. Or I am making some mistake. Let me see. Since there is no mistake, so this is 2 is 8. So the matrix is a little bit uh, reversed actually. This here this will be 8, and I think here this will be 5. And u is equal to 3. Let me say at 3 is equal to 0. So this is 2 by 3. This is 16 minus 9. So so 9 minus 16 is actually 7. So so this become what you see, this become this is 16 minus square, so 3 3 is 9, so 9 minus 16 minus 9 is 7, so this is 14. Now whatever this is 3, so s is 3 here, so how can this be 3? This is 3. 3 by 3, then 16 minus 9, what is it? 7. Correct? So this will be 7. Again I am repeating. At the third node, this is your 3, 0. What happens is x by 3 bar 16 minus x square. This is the equation. So 3 by 3, 16 minus 9. Correct? So this is the matrix. So what? So these will be 7. And what happens with the second value? So the second value is so the second value is actually 8. What happens to the first value? That is the first value. So this is what the 1, 0, 1 by 3 multiplied by 16 minus 1. So this will be 1 by 3 into 15, which will be 5. So this is actually incorrect to write this. Write this. So this is not 8 also, this is your 5. This is correct. So you can understood how U1 is found out, how U2 is found out, how U3 is found out for the with the help of the equation, this equation. Correct? Now the next step is, as you know, this is for the first initial stage. The equation, this equation is valid only for the initial stage, not for the entire stage. That is why what we have to do is, in case of the time scale 1 and 2, yes, the boundary condition stands, but we do not have the value of E1, U2, U3, U4, U5, U6. And hence, what we do is we use that rectangular solution. So what happened is here, first let us see, first we take this u1, this first term u1. So this 0 will be your a, this 7 will be, this is not 7 actually, this is actually 8. So this is the mistake. This is actually 8. This is actually, the 7, and this is 5 as it is. So this is u1. So this will be your a, as I have described earlier in the earlier presentation. This 8 will be b. Then you come here, c will be 0, and d will be u2. So what will happen is this u2, sorry, u1 is equals to 1 by 4. A is your 0, B is your 8, plus C is your 0, plus D is your u2, another one. So this will become your u1 is equal to, this is coming as 1 by 4, 8 plus u2. This is first equation. This is the first equation A, let us say. Now for u2, what happens? This is 1 by 4. This is 1 by 4. So here A is equal to 5 plus this B. This B is equal to 7. C is equal to 1 plus D. D is equals to U3. Correct? Okay. So U2 will be equals to 1 by 4, 12 plus U1 plus U2. And then similarly we'll get U3. So this is for the equation B. So for equation U3, you see U3 will be equal to 1 by 4. A will be your 8, plus B will be your 0, plus U2, plus 0. So here you see U3 is your 1 by 4, 8 plus U2. So this is your equation C. And then accordingly you can find out U4. What will be your U4? U4 is 1 by 4, then 0 plus U2 plus 0 plus U5. And for U5, 1 by 4, U1 plus U3 plus U4 plus U6. Right, so these will be your equation. This is equation D, equation E, and U6, ultimately U6 will be your U2 plus 0 plus U5 plus 0. So 1 by 4th U2 plus U5. This will be your equation. Correct. Okay. So is there an U2 plus U5? Yes. U4 and this U6 is common, but we can find, but in this way it will not work. So what we will do is first try to, this is equation A, correct. This is U2, this is U6. So do it. So put U6, this is U6. Put U6 into equation E in this place U6. Okay. Then put U5 into equation D. Then put U4 into equation this U4. You get this U4. So you now put it in the equation U4, that is in the C. Then accordingly you go for equation B. And at the end of equation A, what will happen is you will see that these terms will come and you will find that you have got the equation U1. You have find out the value of U1. So here you can, what I want to say is, want to say is from equation A to F there is 6 equation and you have 6 unknowns. So you can easily solve those equations with various available methods. You can use any one of them. So what I was suggesting that you put goes on putting from U put the value of U6 as given in equation A into equation E, then U5 to D, then U4 to C, then U3 to B, and then U2 to A. So ultimately what will happen, you will get the value of U2. Okay, once you get the value of U2, again come back to E. If there is U2, so you put the value of U2 there, and then you have your U6 again. So here U6, you put it into U5, then U5 to U4, then U4 to U3, then U3 to U2, then U2 to U1, and then this time what you will get? You will get the value of another U. Okay. So in this way, by chain reaction, you can solve this 6 equation to find the 6 unknowns. Okay, so this is what we have to do, and it's a very easy method, and by which you can use Crank-Nicolson method to find the temperature at each internal node for a rod where the boundary temperature has been given. And it can be found out for the initial time, also for the next time. The only thing is that you must know how to solve binary equations fast, such that you can solve this, or you can find the solution as early as